Yeah, Dr. Rakesh Matam expertise lies in the higher layers of the different communication protocol stack, including on-cloud and fog computing, networking, and security. He has received his PhD degree from IIT Patna, India in 2013. So Dr. Matam has more than 12 years of cumulative work experience in both industry and academia. He has multiple research collaborations with different industries partners, along with CDAC. He is the principal investigator and co-principal investigators of 8 funded research projects sponsored by different funding agencies. He also acted as expert consultant for a few multi-funded research projects. He also published over 100 journals and flagship international conferences. He serves as associate editor of IEEE Access, a multidisciplinary IEEE open access journal. He has over 1800 citations and an H-index score of 18. So he is a senior member of IEEE. Yeah, thank you, sir, for wonderful profile. I think our dear participants so will get a good knowledge from you, sir. So in this particular session, yeah, I'm hand over the session to Sir Rakesh, sir. So please proceed.
Yeah. Good afternoon, everyone. Before we start this session, I would make a small disclaimer. Venkatramulu sir, Shankar sir, these all people have taught me. So they shouldn't be addressing me as sir. They should be calling by my name, Rakesh. So it's an honor that, thank you, sir. It's an honor that I am giving a talk basically on this topic. It's been a long time. I wanted to visit the institute multiple times, but I could not. However, through this FDP, I am connecting remotely. Oh, hopefully, I will visit during my next visit to the stay. I'm basically from Hyderabad, so when I visit Hyderabad, I will make it a point to visit my institute. Without any further delay, I'll start this session. My topic today is on introduction to cybersecurity. Let me share my screen. Okay, so is my screen visible?
No, sir.
No, okay. Slightly the layout has changed and I am, let me check. Share window. Yeah, I think now it is visible. Is the screen visible?
Yeah, visible, sir.
Yes, sir.
Yes, sir.
Now it is
Yeah.
visible, sir.
Yeah. Okay, so let me change the slide and see if slides are changing. Are the slides changing?
Yes, sir. They are changing.
Okay. All right. So,
Yes, sir.
okay. So let me actually first quickly tell you about what I would be speaking about in this particular topic. On this particular topic, and I hope all of them are either from this background of networking and cybersecurity, if they are not, then I think some of them are enthusiastic to build a career or build their profile in this particular area. So with this assumption, I am going ahead. So some background noise is there. Can somebody please mute themselves if they are? Yeah, thank you. So I am assuming that all of you have some brief knowledge about it. So the first few slides will be slightly introductory, followed by the main focus of this presentation, that is IoT malwares, right? So we all know this is the definition of cybersecurity, right? So this basically is an umbrella term that considers lot of other security components. For example, when we are saying cybersecurity, we are not only dealing with your at the endpoint security like your computers or servers, etc. We are also dealing about networks, mobile devices, right, and all the components that can be possibly connected to the internet, right? So cybersecurity basically deals with securing all these components. That is why basically if you look at it in a umbrella view or like a high level view, you can see that cybersecurity basically is comprising of other security sub areas basically, right? So once we are dealing with the issues that are plaguing this particular this particular field, you are considering not only some specific issues but also all the related issues that are related to cyber world, right? So what can be these type of threats? They can be very simple threat like unauthorized access to basically complex attacks like malwares, viruses, ransomware, denial of service attacks, and all other related cyber attacks. So what is the relationship of cybersecurity with other terminology? If you can look at there are multiple components of cybersecurity. When you have something called as information security, you have something called as computer security, you have something called as network security, right? These are all parts of your larger domain. But if you critically see what exactly we are talking about, is we are talking about this circle basically. We are talking about this circle, which is comprising of ICT, information and communication technology security, along with other non-information based assets that are vulnerable to threats via ICT. For example, your networks, right? This is also part of your cyber security. But if you look at information security, this involves digital information that needs to be protected under cyber security, and non-digital information means, for example, information that is stored in some other format, maybe files, let us say, right? That also comes under information security. So we are dealing with this type of this type of security requirements now in this particular field of cyber security, right? Cybersecurity basically has evolved over a long period of time, maybe say around 50 years basically, right? So it has evolved into these four principal components that we call them as today as network security, cloud security, endpoint security, application security, and internet security. These are all components of cyber security today, right? So new components have added. For example, in the last 10-15 years, cloud security has taken a very critical role as and when our applications are moving to the cloud, right? Especially with the advent of mobile phones, application security, API security, all those things have also evolved, right? With the rapid use of internet, different type attacks remain the same, but the way in which those attacks are launched or those attacks are targeting, right, that has also changed over a long period of time, right? So that we will look at how these have changed and how they have evolved. For example, if you look at network security, you have all these components that we call as network security, right? We have something like intrusion detection systems, we have something like firewalls, we have antivirus software. This is part of your endpoint security. You have you have security policies, that is part of your security ecosystem, but not directly related to any kind of threats or attacks. You have something like secure communications. You have something related to data base itself, and different types of techniques how to prevent malicious access to this data, right? So this basically we are looking at all these components put together, right? So when you have all these components put together and the components that we saw in the last slide, right, it becomes a very complex domain, right? So over this period of 6 days, I think the lectures have been arranged in such a way that there will be connection about multiple components and each person will be talking about different topics in this particular field in depth, right? So it basically, if you remember these things, then you can actually understand better over the period of time, over the period of next 5 days, right? So let us look at the timeline, how cyber security has changed and what is it today, basically, right? When computers developed, right, especially in the 1970s, 60s to 70s, when first ever computer virus program was launched, this was called as creeper worm, right? So basically it transferred itself to all the connected machines from one machine to another, right? In the 1980s, the first firewall technology has been developed, right? 1990s rise of virus and worm was seen, right? Where if you have like ever studied computer security or cryptographic and network security, you must have heard something called as Morris worm, right? It was named after scientist Robert Morris. He basically invented that program to count the number of machines on the internet, if you remember, right? So in 1990s, rise of viruses and worms happened. With that, in 2000s, basically in the late 90s, internet started to get wide attention. So basically with the advent of internet, a huge increase in the number of cyber attacks happened across the world, right? So that's how different types of security solutions also came into place in early 2000s, right? And the landscape has changed dramatically from 2010 because of the mobile phone revolution. So more and more smartphones, like if you remember 2008, 9, I think was the first time when smartphones like Apple launched its iPhone series, right? So 2010s was the time from which mobile devices came into picture. So once you have mobile devices, then automatically cloud also came into picture, like Apple Cloud, right? So iTunes, etc., if you remember, those were all cloud based applications. So from early 2000s, 2010, the rise of mobile devices started increasing and slowly IoT devices came into picture, right? This is I am talking about from an Western country's perspective, right? So if you compare it with Indian landscape, slowly we are slightly slow in the adoption of these technologies, because naturally, because of the gap in technology deployment, right? So with So in 2020s, the rapid change has occurred because of the COVID-19 spread, right? You must have all remember or recollect those days where suddenly video conferencing usage shot up, right? Cloud based services have increased exponentially. So in the same, cyber attacks have also increased in the early 2020s, right? So now we are in 2020s, basically 2025, right? So with this, the landscape has changed. That means the kind of solutions that we were applying in early 2000s were not applicable today, because a lot of things came into picture, like availability of compute power, right? That is a main change that has occurred. So basically attackers had this uh, huge exposure to computing power. So once you have computing power, then different types of new variants of the same attacks can be launched, and the impact of these attacks can also be increased because the number of devices through which this attack can be launched can be increased. So that's what has changed from early 2010s to 2020s till today. That is, the nature and the impact of these attacks have grown significantly. So parallelly, the solutions have also improved by adopting newer technologies, especially in terms of AI, right? Especially in terms of AI ML techniques, right? So what role does AI play in these cyber security, right? We all must be aware, and we must be using artificial intelligence in multiple different mechanisms. Some way or the other, we have been exposed to different types of AI techniques, right? So what basically AI does to this field of cybersecurity is, it it not only AI can be used both by defense mechanisms, AI can be used both by attackers, right? So it is like a uh, balanced figure for both attackers and solution developers, right? So what AI has done, especially in terms of defense techniques, is it has enhanced the threat detection and analysis, right? Quite natural, because of the humongous amounts of data that is being generated, it is manually impossible to do the analysis in real time, right? So that's where this use of AI plays a major role, right? Vulnerability management and patch prioritization, that can also be achieved well with the help of AI, right? And use of machine learning techniques have increased the spam and phishing email detection, spear phishing techniques. Different types of advanced solutions have been enabled or were possible only because of the use of AI, right? And one of the most important application of AI is malware detection and prevention, right? So if you remember, if you recollect, earlier means early antivirus softwares typically used signatures to detect antiviruses. Over a period of time, they started using some kind of analytics, especially anomaly based approaches, distinguishing what is a natural behavior and what is a normal behavior and what is an anomalous behavior for detecting any kind of intrusions or any kind of malwares, right? So with the advent of AI techniques, you can actually use intelligent techniques for detecting malwares and their prevention as well, right? And also user behavior analytics can be more carefully observed using ML and other deep learning techniques. Enhanced security risk assessment can be done with the use of AI techniques. Automated incident and response techniques can also be part of AI, right? So one of the major challenges, for example, if you have a large organization and you have lots of machines that are connected, the major challenge is the number of alerts that are generated, right? So basically you must be having 3 or 4 security personnel handling, let us say, alerts, right? Handling so many number of alerts is typically very difficult. So what happens is, with the abundance of information, major alerts might be missed, right? So this can be automated using AI techniques, right? So that is also one of the major advantage of using of AI, right? So when we are talking about AI, what exactly is happening? AI basically allows us to design applications through its assisted intelligence, right? So you can use AI to improve the intelligence of your applications. You can use AI to augment solutions that were typically not possible before. And you can automate different types of actions using AI, right? So basically all solutions that we can think of fall in one of these categories, either assisted intelligence or uh, or augmented intelligence or autonomous intelligence, right? These three can be done using AI, right? So what are the key technologies that are available for us? We will start with something like machine learning, right? You like decision trees, random forests, support vector machines, clustering techniques, right? Where they can be used, machine learning can be used in intrusion detection systems using support vector machines for anomaly detection, malware classification with random forests, etc., right? So you have something like deep learning techniques, you have CNNs, recurrent neural networks, autoencoders, right? So CNNs for detecting malicious traffic patterns in packet capture, recurrent neural networks for analyzing log sequences, autoencoders for anomaly detection in system logs, right? You can also use like natural language processing techniques, right? You have huge amounts of data, right? So when you have huge amounts of data, you can use techniques using like NLP, like BERT, NER, IOCs to extract incident of compromises, right? All these techniques can be used to boost the performance of your cyber security solutions. You also have like, so whatever you can think of, machine learning, deep learning, natural language processing, generative AI techniques are now being used, like GANs, generative adversarial networks, autoencoders, right? Large language models especially have been finding place in the design of solutions for cybersecurity, right? So more and more different types of solutions are possible with the advancements in AI technologies, right? So how do we use these different AI tools for developing solutions? That is a core question that we need to find answer for, right? So that's the main point. It's not like one of the, since you have reinforcement learning techniques or deep learning techniques, you cannot use machine learning. That is not the case, right? Every individual solution have their own place in the design of cyber security solutions. One of the topic that I am going to discuss is about what happens when you have something like IoT devices in this cyber security landscape. What kind of solutions will be available? That's what are my next few slides. I think this is a repeat of the previous slide. So what has changed now? So what has changed now means basically, before IoT devices came into picture, right? You had several solutions. Like, let us look at from the endpoint perspective, from a user perspective. Let us say I am the user. I am the user, normal user, not a like business case user, or not. I am not in an organization, right? I am just, let us say I am a student who is studying in an institute that is connected to a network, and through my network I can access internet, right? This is the landscape, this is the scenario we are considering, right? So what are the normal security solutions that I can think of? For example, I am using a laptop. I will have my antivirus, firewall, Microsoft Defender, for example, installed in my machine. So whatever I am trying to access, my traffic flows through this firewall basically, right? So these solutions are already existing, and these solutions are evolving every day. So what has changed? What has changed? Why newer technologies need to be adopted to address the same problem of security, right? So what has changed that we need to identify, right? So if you pay close attention to the cyber security field, the problems remained the same, but the range, the scope, and the impact has changed, right? So basically, if it is very easy to protect a network that is where everything is under control, right? For example, if you take the security of a large country like India, right? So it is very difficult to secure all the borders, especially, right? Because the landscape is very different, right? So that is what, when the landscape is different, you have multiple opportunities for the attackers to exploit, right? That is what has changed in the past, let us say, decade. What has changed is the number of devices that are getting connected to our cyber world has increased exponentially, right? As it has increased exponentially, the major reason, starting from mobile devices, let us say, is the advent of these smaller devices that we call it as IoT devices, right? You will all agree that protecting a computer, a typical computer like a laptop or a server or a desktop, or all these endpoint devices is much easier compared to protecting, let us say, your Alexa device that is present in your home, or an industrial IoT device, or a BP monitor that is connected to the internet, or for example, like that, there are multiple, or your security camera that is continuously monitoring your home or industry or any particular area, right? So when these devices are connected to the internet, right, that means these devices either are accessible through your internet or through your network, right, or they can be accessible across the internet directly, right? So once you have such devices, right, the major challenge is whether these devices are operating under the secured perimeter of your network, or they are open, right? Since the number of such devices is very large, protecting each of such devices is almost impossible, right? So that is a major challenge that cyber security field is facing right now, right? So if you look at the question why IoT security became critical, basically explosion of devices, like suddenly there are like 25 billion devices that are connected to the internet. Like in mid 2010 there were around 5 billion devices, now it is 25 billion, right? So it has grown 5 times, right? So it is almost impossible to protect each such device, right? You have varied fields that were not earlier part of the network, right? Smart homes, wearables, industrial IoT, medical IoT, right? All these are non, all these are areas which are not uh, primarily supposed to be connected to the internet. For example, you in your smart home, you cannot expect that each home will have somebody who has knowledge of computer networking or security, and they will be very careful while installing these devices. No, it is not possible, right? And you also have advent of wearables, like you have smart watches, right? Glucose monitors, BP monitors, right? All those small devices that can be part of your that you can wear basically, right? And medical IoT, for example, we have seen that these CT scan devices are connected to the internet. The angiogram devices are connecting to the internet. The ECG devices are connecting to the internet, right? So once you have these non-specific computing devices connecting to the internet, then definitely there is going to be challenge, right? What does that device mean is that each device means an entry point for the attacker, right? So you must have come across this term called as attack surface, right? Attack surface is basically the point through which an attack is happening, right? So with the advent of new devices, new entry points have been created. So the more the entry points, the more vulnerable your system is, right? And also basically these devices have unique constraints, that is basically limited computing resources. For example, if you consider a small microprocessor or a microcontroller, they cannot run a typical antivirus or a typical IDS system, right? So once you have something open on that particular device, right, it is vulnerable. It becomes vulnerable if there is a vulnerability that is existing, right? You have a diverse ecosystem, that means different vendors, protocols, etc. Often these devices are poorly updated or patched. That means like if you go on Amazon and search for security cameras, there will be at least 50 different or 100 different vendors that are supplying security cameras, right? So if you look at, you just buy the cheapest product, let us say, right? It is not necessary that particular product will be serviced beyond a point. The software that is provided by the device will be updated, right? Patched, right? Patches might be released, might not be released, right? So all those things happen, right? So that's why each device means new entry point for the attackers. So this IoT ecosystem basically has created lot of risks, basically because of the insecure devices. Once you have a lot of these insecure devices, they can lead to different types of attacks. That all depends upon the capability of the attacker. Now once you have an entry point, what the attacker can do is completely dependent on the capability of the attacker. We will show some examples of those attacks. These IoT devices not only lead to security risks, they also lead to privacy risks. That means your personal data getting exposed, right? Imagine, let us say your smart TV, right, constantly has its microphone on, for example. So basically it is hearing all the conversations that are happening, right? So these devices might be relaying data to the servers that might be not authorized, right? So these all risks come into picture, right? And once such a security risk or security threat happens or security attack happens, there are large economic costs that needs to be considered, right? So that's why the impact of these security attacks and the need to study these IoT security attacks is very much crucial, right? So if I'm continuously going through slides, if there is anything that you wish to stop, right, please let me know. I can take questions in middle as well, right? So as I've said, there are several security challenges like resource constraints, fragmented landscape. Fragmented landscape basically means diverse architectures. Diverse architectures, like for example, uh, the Alexa device might be a microprocessor. Your security camera might be a microcontroller. For example, microcontroller also there are hundreds of microcontroller implementations. Like you have something like ESP32, you have something like Arduino boards, right? These are off-the-shelf devices that are available for us, right? Device architecture varies, right? And there is lack of standardization across vendors. For example, all network protocols are standardized, right? So we know that you have application protocols like HTTPS, like a lot of, it's a standardized protocol. TCP you have standardized, you have IP standardized, you have different MAC layer implementation standardized, right? All these are standardized protocols. But when it comes to IoT ecosystem, a lot of implementations are proprietary or customized, right? So there is no validation verification of these devices. So there is no standardization as well, right? So if you go for standardization devices, let us say, I'm not saying that there are no efforts in standardization. There are a lot of efforts as well. But as you go for a standardized product, its cost increases immensely. For example, you get a security camera at 3,000 rupees and you get a security camera that is certified by Intel at 15,000 rupees, right? So obviously, like there will be a certain market for 3,000 rupees devices. There will be a certain market for 50,000 devices, right? So, so lack of standardization and lack of enforcement, basically, how can you enforce, right? It becomes very difficult. So that also is a major challenge for enforcing security, and very short development life cycle, right? For example, we observe that like mobile phone companies like Samsung comes with a different model every year, right? So they know that this year I have released like Galaxy 25, then next year it will be 26, right? Like that, iPhone 15, 16, 17, every year one product. So there is at least 1 year time for them to release a product. But if you look at IoT devices, the product development life cycle is very short, typically in terms of months, right? So when you have such short development life cycle, right, uh, you cannot expect the level of security that you expect from a typical computing product, right? And vulnerable deployment, this is one of the major reason for these attacks to happen, right? Many devices operate in open or insecure environments. Open in insecure environments means, for example, there might be a possibility that the attacker has access to your physical device, or the attacker has access to tamper with your device, right? So that basically increases the attack surface. That's what I was talking about here, increased attack surfaces, right? If you try to summarize the challenges in IoT ecosystem, right? This is what we can basically categorize into. One, because of resource constraints. Two, because of fragmented landscape. Three, because of vulnerable deployment scenarios, lack of standardization, and diverse ecosystem challenges. So what type of attacks are possible on this landscape? Basically, what type of security attacks are possible? Whether it is only whether there is any correlation with security attacks that happen in a typical computing environment, or are these attacks different, or these attacks like, or are these attacks similar, same, different, right? We do not know, right? Let us look at what type of attacks are possible in an IoT environment. Typical classification of attacks is either an attacker is actively trying to do something, mainly to do what? Whether to impact your service, whether to access your data or whether to use some kind of additional injection type of injection of messages, right? That we call it as injection attacks, right? Or basically the attacker is not doing anything, he's not manipulating anything, just trying to gather information by being a passive part of your network, right? So these two classifications already exist, right? But and layer wise classification also exists, right? Means at what layer the attack is basically happening, whether it is happening at the sensing layer, whether it is happening when you're communicating messages, or whether it is happening when you have some kind of middleware, whether it is happening on the gateway or whether it is happening on the application, right? All these are various points at which the attacker might target, right? So this classification also exists. So similarly, there is another classification, basically physical attacks, network related attacks, software attacks, and encryption attacks, right? These are all different categories of attacks based on the nature of attack, right? So all these do not typically capture how an attack is launched, right? So what we have done is we have tried to come up with something, because you see something like uh, denial of service happens in network attacks. Denial of service can also happen on software category, right? Like man in the middle attack can happen on the network, man in the middle can also happen in the encryption related attacks, right? So one attack might be happening at multiple layers, right? So what we have come across is, if we could, this is also another classification strategy. This was designed by Al-Sahrani et al, right? This, they also classified attacks based on different layers, right? So I will show you a new type of classification strategy that will allow, that will make your understanding about attacks slightly better compared to the previous classifications, right? We can look at attacks basically from where the vulnerability is exploited. Where is the vulnerability? At what place the vulnerability is exploited, right? If we look at these attacks from that particular viewpoint, we can see that attacks can be basically classified as device level attacks, right? Device level basically means that you are exploiting something at the device level. Means, for example, you have a security camera, let us suppose, right? So if you are exploiting the firmware of the device, so the attack is happening at the device level. Or if you are exploiting sensors on the device, right? Or if you are exploiting the authentication mechanism on the device, right? All these happening at the device level, so that we can categorize them as device level attacks, right? And the second type of category of attacks you can classify as attacks that are only targeting network or communication protocols. Network or communication protocols means when your device is interacting with any other device, right? The interaction is happening through the network. When some message is flowing, right? Then active type of attacks can happen, passive type of attacks can happen, but all those attacks are targeting the network protocol, right? And the third basically category is application level, where you are exploiting the software, right? So if you put these three things together, you can categorize any type of attack, right? Because the attack will happen either on the device, either while you're communicating with another device, or on the software that you have used to connect it to the device. For example, let us take a small example of your Alexa device, let us say. If the attacker is targeting the device itself, means the the small Alexa bot that we have, then it will fall under the device level. If the Alexa device is communicating with your access point, let us say. So if your attacker is targeting the communication between your device and the access point, then it will fall under network. And let us say you are using a software application. Let us you use a software application. Let us say you have a smart bulb, right? You have an application that is installed on your phone. You can access that particular smart bulb or device through your phone, right? So if the attacker is targeting this particular software application on your mobile phone to target the device, then it falls under application level. So having this simple classification will solve a lot of your attack related confusion that was existing in the previous classification approaches, right? So this is a new classification category where you have attacks at the device level, network communication protocol level, or application software level, right? We have we have developed this classification strategy. You can see that one attack can form under multiple categories. That's all right. For example, malware. For example, if you take an attack like malware, right? This is existing here. This is also existing here, right? And this is also existing here, right? So one attack can originate at the application level, can flow through network level, and can be targeting at the device level, right? So this particular point is very important because you can look for uh, indicators of compromise that are happening at the software level. You can look at the indicators of compromise happening at the network level. You can also look at the indicators of compromise happening at the device level. Having this clear advantage of where you can find the proof for an attack, right, will help you in designing better solutions, right? So once you have these wide variety of attacks, right? One of the major attack vector that these IoT devices are susceptible to is malwares. We all know what is a malware. Basically, we all are aware that malware stands for malicious software, right? Since these devices do not have strong solutions to handle malwares because of the constraints that we have discussed earlier, right? The entire cybersecurity ecosystem, majority of the efforts goes into design of solutions like intrusion detection systems, intrusion prevention systems, right? SIEM and SOAR solutions, right? All these like honeypots, etc., right? Basically, to study UTM, for example, Unified Threat Management Systems, right? All these are solutions that are aimed at trying to protect or trying to stop intrusions into our system, right? Intrusions can happen in multiple ways, right? And malware is the major source vector for these malwares, for these attacks, right? Why it is very important to study about these malwares is because this is the major vector that is targeting different types of cybersecurity products, right? So once you have these IoT devices connected to the internet, IoT devices are not the only devices that are vulnerable. Now, using these devices as launchpad, your regular computing infrastructure can also get impacted, right? The point that I'm trying to make is you have a large network of devices, right? Different types of devices are there. You have servers, you have computers, you have cloud products, right? All these are connected, right? Now, along with it, you also have some IoT devices. So if there is a vulnerability on the device, that will be first targeted. It will be an entry point to your home, right? To your network, right? Once you have that entry point, you basically are having a lot of means then it depends upon the capability of the attacker basically, right? So that's why it is the major focus is on malwares. So why is it very easy to target IoT devices? As I've said, one of the major thing is weak security, right? So if you have done any kind of security course, the first layer of defense that is offered by any kind of computing system is authentication, right? I guess everybody agrees. For example, if I want to protect my phone from somebody else accessing, I will simply put a password, right? So the capability of an external means other any person other than you trying to access your phone, it all depends upon the kind of password that you have. Let us say you have simply put 12345 6 as your passcode, right? So it is like very natural for any attacker, anybody who has access to your phone, to check for natural combinations of passcodes, right? If you have default credentials or weak passwords, right, then it becomes very easy to crack those systems. Followed by default credentials and weak passwords, right? So majority of these IoT devices that they come with default username and password. For example, admin, right? Admin and the password is password. They will suggest that the device manufacturer will suggest that once you set up your device, please change your password, right? That is just a guideline, right? Majority of the users or lot of users do not change their passwords, right? That becomes the easiest point to attack, right? So one can argue that no, if I change my credentials or if I change my password, then will my device be secure? Yes, of course. Better than default credentials device, right? So once you have this problem sorted out, you have other problems, right? I will show you what are the major causes for weak security, right? Followed by it is unpatched firmware vulnerabilities. We have already seen security vulnerabilities. Most of the major security attacks have happened in the literature only because of the carelessness of the user, most, right? And the third major reason is lack of security protocols and encryption mechanisms, and followed by the minimal detection that the IoT ecosystem has to offer, right? What are the primary goals of IoT malware? Basically, you have distributed denial of service attacks, right? Since these devices are small, large number of devices are there, the attackers can target similar type of devices to launch large scale of distributed denial of service attacks, right? If people who are working in this field, they must be aware of the something called as Mirai botnet. This attack happened in 2016, and there are like numerous variations of Mirai botnet, right? They have infected thousands of IoT devices to launch massive distributed denial of service attacks, right? Lot of major service providers were affected by this Mirai botnet. Next, data theft, device control, and espionage, right? All these are primary goals of IoT malware. For example, these are the popular IoT malwares. For example, this virus story, the propagation method means how it goes from one devices to another device is brute force telnet. You know that telnet is a port that is typically used for remote login, right? So if the port is 23, if this port is open, basically the attacker first tries to brute force. This is a detailed life cycle, scans for telnet ports, brute forces login, infection with the command and control link, then followed by data collection and persistence. And once this happens, it self propagates. The malware name is Trojan. The propagation method is phishing and malicious downloads, right? Same technique it uses. You have something called as GAFGit or Bashlight. It also brute forces telnet and SSH terminals, right? It scans for telnet ports, brute forces login, infection with command and control link, data collection and persistence, and self propagates, right? You have Kenjiro. These are all popular IoT malwares. Like that, you have Okiru. It only targets ARC processors. Hakai, IRC bot, Mustik, all these are popular malwares and which have similar life cycle of techniques that are used, right? Like for example, you have Mirai. If you see, it scans for telnet ports, brute forces login, installs malware in RAM. This is very important. Links to command and control server, launches distributed denial of service attacks, self propagates. It can be dormant or reinfection after reboot, right? So this is how Mirai basically goes from one system to another system. What is the difference between this IoT malwares and traditional malwares? That is very important to understand because only then you can design solutions that are targeted specifically for IoT malwares, right? You know that traditional malwares basically target PCs, laptops, servers, mobile devices, but IoT malwares specifically target smart devices. Traditional malware, the major route in which attacks happen is through phishing, malicious downloads, and software exploits. Isn't it? Phishing, somebody has opened a phishing email. Malicious downloads, you are downloading malicious downloads, and software exploits. If there is a software vulnerability and that is exploited because you have not installed a patch, right? That is the major routes through which traditional malware enters your system. But IoT malware's main reasons are weak passwords, unpatched firmware, and insecure protocols. The purpose, you have botnets, distributed denial of service attacks, surveillance, and ransomware. If you look at traditional malware, the impact is more data theft, system corruption, ransomware, espionage, right? Complexity, IoT malware is simpler, very simple, exploits limited device resources. Traditional malware complexity is advanced. Basically, it is difficult to launch. Different types of evasion techniques are needed, and you also need to means the malware needs to exhibit polymorphism to avoid being detected. Security challenges, poor built-in security, unpatched devices, and scalability. Traditional malware detectable by these existing tools like antivirus, firewalls, frequent patching, etc. might be needed, right? Impact is very huge, right? Both malwares impact is huge, but here the real world risks are there, right? That means, for example, a insulin pump, if you have read a news, right? For example, in Europe during COVID-19, I cannot recollect the name, but there was a large NHS of UK. They were the insulin pumps were targeted. Basically, remotely the insulin pump can be operated, and like if you all are aware that if you can remotely access an insulin pump and control how much insulin can be provided to a patient, right? It can result into serious security implications, including like loss of life, right? So there are some real world risks associated with IoT malwares. Please look at these top 10 vulnerabilities. This is the top 10 vulnerability. People working in cyber security know this particular organization called as OWASP, Open Web Access Security Project, right? They frequently publish top vulnerabilities across different platforms, right? They have published this particular list of top 10 vulnerabilities. You see that the first vulnerability that they have identified is weak passwords. Second one is insecure network services, insecure ecosystem interfaces, right? Lack of secure update mechanisms, use of insecure or outdated components. Like, for example, you might be using lot of APIs to build software related to this IoT systems, right? So when you are using insecure or outdated components, they also will result into vulnerabilities, right? Like that, you have top 10 vulnerabilities. These are the top 10 vulnerabilities even today. It's not like this data I am presenting is 10 years before data or like 5 years before data. No, this is relevant today, right? These are the main vulnerabilities that are exploited, right? Yeah, I want to go into the details of these malwares, but looking at the time, I'll just show you main malware that we can think of. Whether I have okay, I will discuss this particular malware. Right, this is called as KG malware. Right, this is used to launch distributed denial of service attacks, right? It takes advantage of weak or default passwords to get access and propagate. It mainly targets two types of devices, that is ARM based architecture, right? MIPS based architecture, right? People working in computing field, they know these two platforms, ARM platform and MIPS platform. Most of the devices, IoT devices, are ARM based devices, and there are a significant number of devices that are based on MIPS architecture, right? For example, the devices that are affected by this malware are this TP-Link Wi-Fi router that runs a Linux-based firmware, Hikvision cameras, Siemens controller that is majorly used in industrial applications, and this Fitbit watch Versa 2, right? So these devices were targeted by, means these devices were vulnerable by this Kaiji malware, right? So this virus originated in the year 2020, and main target of this device was Linux based servers or and IoT devices, and they used SSH brute forcing, right? It's what can Kaiji malware do? It can launch different types of distributed denial of service attacks, like IP spoofing. You all know IP spoofing, right? So IP spoofing basically involves you are using spoofed IP addresses to target a machine, right? And SYN ACK flooding, right? The TCP three-way handshake involves sending SYN packet, acknowledgement packet, and SYN ACK packet, right? So that particular mechanism is used by this Kaiji malware to launch distributed denial of service attacks. So how does it initialize? It basically once it does SSH brute forcing and targets root users, right? It establishes an SSH connection. You all are aware of SSH, right? Secure shell connection, right? That creates a directory in this particular library, right? Once that is there, the malware is then installed as a common utilities application like netstat, ps or ls command, right? So basically netstat is a network statistics tool, right? So it appears as if it's a network statistics program, so to avoid being detected, right? So these are the core routines. Basically, these are the main subroutines of each program, like do link, main do task, DDoS rootkit, right? These are the main routines of this Kaiji malware, right? Uh, and these are the main shell programs that it exploits, right? Main rung shell, main rung host, main rung dingshi, main rung rung ran, and main run kg, right? These are the main services that the kg malware uses. This is the life cycle, right? Infiltration via SSH brute forcing, establish a SSH connection, activate the bash script, create directory in this particular folder, install malware as common utilities, decrypt the command and control server, register with the command and control server, receive commands for distributed denial of service attack and SSH spreading, and execute distributed denial of service attacks, right? This is the life cycle of one of the popular IoT malware. We call it as Kaiji. Similarly, we have another malware called as Bashlight. I am skipping through this Bashlight in the interest of time. Now let us look at solutions for this malwares, right? That is the main part of this talk. How we can leverage artificial intelligence and ML techniques to address these attacks, right? Since here we are assuming that a malware is an attack that is happening from outside, what we can do is that we can have some kind of defenses on the perimeter of our system, right, of our network at the end point, right? So what kind of solutions we can use? We can use something like machine learning. You have signature based detection techniques, you have anomaly based detection techniques, you have behavioral analysis techniques, and more recently you have something called as federated learning techniques, right? In machine learning you have several types of learning techniques, right? And in deep learning you have several types of learning techniques, right? I have not included newer techniques like Gen AI, but for IoT malwares, these two types of solutions, including means machine learning, deep learning, federated learning, all these three techniques can be employed to detect malware, right? Let us look at this solution from a high level point of view, right? Something is happening over the network, reaching your device, that you have to identify, right? For example, somebody is doing a brute force on my device, or somebody is trying to exploit a vulnerability on on the network protocol or on the device to inject a malware into my system, right? How can I detect that? First, first and easiest solution that I can have is I have a signature of that particular malware. Let us say that I have my malware is Kaiji or Mirai, let us say, right? I have the malware and I know that this is the signature of that malware. Let us say a secure hash, right? So whenever the malware is entering my network or whenever the malware is targeting my system, I can run this signature based detection mechanism, and if the signatures match, then I will prevent further access for that particular malware or attack, right? That is the most simplest, easiest possible solution, right? The next possible solution that we can think of is anomaly based. Means you have defined what is a natural or normal behavior, then you are looking for any kind of abnormal behavior, right? So that kind of analysis you can use in behavioral analysis techniques or anomaly detection techniques also, right? Anomaly techniques and behavioral techniques both share slightly common features when they are trying to flag any kind of attack, right? So like let us say you are trying to remote login to a device, right? First time you have given a wrong password, right? Second time you have given wrong password. Third time you have given wrong password, right? Three times you have given wrong password, right? Normally means it is there is no attack, just it has happened naturally, let us say, right? You have, if you have any kind of anomalous system running, then it will flag this as an anomaly, right? And after logging in, let us say you are doing something which is not your natural behavior, that can be captured using behavioral analysis techniques, right? So these three are most widely used techniques, right? But complex attacks, when they are happening, right, they might not be captured by these three techniques, right? Then we need some kind of learning, that is where we are using these machine learning based techniques, right? And the depending upon the computing capability that is available, you can either go for machine learning techniques, deep learning techniques, and federated learning approaches, all right. So these are the ML and DL approaches. What they do, they learn attack patterns from data to enhance detection accuracy, right? So these are effective against novel and evolving threats, but require, they basically ML and DL based approaches require labeled data. Means you need to label, means means you need to classify that this particular packet trace is an attack, and this particular packet trace is benign, right? Benign or malicious labeling has to be there, right? There are a lot of works based on ML and DL based approaches. And federated learning, you have like you the basic need for federated learning is the learning is happening in a distributed fashion. So you have smaller models running on different devices, right? All these devices are cooperatively trying to build a singular model to detect different types of attacks, right? So this is a decentralized approach. It is mostly privacy preserving. So you have federated learning approaches as well, right? And there are, as I've said, there are other approaches: signature, anomaly, behavioral, right? All these are evolving approaches. So this is a timeline of ML and DL based approaches. For example, these all different types of works that have been done to detect different types of malware attacks on in IoT ecosystem that are based on, that are using network traffic. Similarly, you have uh, uh, ML and DL for generic attack detection, that is like reconnaissance attack, spoofing attack, and malwares, etc., using network traffic. These are the works that are there or have been done using different types of machine learning and deep learning techniques, right? And these are the works that are using federated learning techniques, right? Now, let us say I want to today start work on these IoT attacks, or for that matter, cybersecurity attacks on cybersecurity systems, right? So how do I start, right? Where do I start with, right? The major challenge in designing um, security solutions is the lack of data, right? Why, when I say lack of data means, let us say I am a company or I am an organization that has been recently subjected to a cyber security attack, right? So I have been compromised, right? So I will have lot of data, right? But me as an organization, will I be willing to share my data with the will I put my data in the open? Most likely no, right? Most likely I will not be sharing my data with the ecosystem, right? Means cyber security solution providers, right? That is natural because it exposes or it removes the privacy that is associated with my users, my network, my systems, right? So the major challenge when working with when designing cyber security solutions is lack of data, right? And lack of real world data. You can generating attack data is very difficult, right? Simulating attacks that happen similar to a real world is very difficult, right? So that is why most of the security solutions that are there in the market are proprietary. They do not disclose from where the data has been generated, and the data is not available for use for the in the open source community, right? So that's why when we want to start any kind of work in this field, you start with data sets. Basically means data sets are these collection of typically network traffic that is having different types of samples, attack samples, benign samples, right? All these are put together. Different types of devices are there, right? So that is the starting point, right? The next, once you have this data, then you need to then if you want to develop serious solutions in this particular field, then you have to have some kind of test bed setup for capturing the data, right? These are the most popular data sets that are available for us to work with different types of attack data, right? If you look at this particular NBA IoT data set, it is of the year 2018, right? This data set basically captures authentic traffic traces from infected commercial IoT devices, right? Like smart homes. If you look at, there are 9 sensor devices. The number of samples are this. They have 23 features, right? They, as I've said, these are the attacks that they have captured. Bash Light, Mirai, right? Bash Light having chunk, UDP flooding, TCP flooding, combo attack, and Bash Light combo attack, right? So detection techniques, one class SVM and IF, all these are detection techniques. There are a lot of works that have done based on this NBA IoT dataset. You have something like called as bot IoT dataset. If you see, the number of devices is very less, 5 sensor devices only, right? Testbed setup is virtual. MQTT this dataset is also having huge number of samples, but the number of devices are very minimal. Let us say 8 sensor devices. Like Ton IoT, one of the more popular, but the number of devices are very minimal. You see 7 sensors only, but the number of samples are also very little, right? CIC IoT, right? This is one of the major data sets, CIC IoT. 105 sensor devices are there. Out of them, 67 IoT devices are there, 38 Zigbee devices are there, and Z-Wave devices are there, right? So the testbed setup is also real. That is why the number of samples is also very high, and the number of features is also very high, right? And you have ACI IoT, which is also having 12 number of devices, and around 11 lakh 75,214 samples are there with 85 features, right? And the number of attacks that they also is more or less decent. This is one of the most recent data set. The setup is industry setup. The testbed setup is they have both virtual and also real devices. The number of samples is also very good. and the number of features is also very good, right? So somebody willing to work on data sets basically can start their experimentation using this particular data set, right? These are the feature comparison among different data sets, right? Source IP address, destination IP address, source port, destination port, different types of transport layer protocols, total duration, timestamp, source bytes, destination bytes, services that are offered, connection states, and missed bytes, right? All these are common features across these different data sets. Like that, you also have other network layer features like source IP, number of bytes per destination IP, MQTT message type, flag, MQTT flags, clean MQTT. These are MQTT specific. These are MQTT specific. So that is why you have all these features are present in the MQTT data set. So what is the major gap when you are talking about these data sets? If you see, if you observe, the environment that they are considered is smart home, smart home, smart home, smart home, smart home, smart home, and only one industry data set. So most of the data sets are capturing data from smart homes, right? But the exposure of IoT devices is very wide. Not only smart homes, but they are also in different other environments like vehicular environment, industrial environment, medical environment, right? So the type of attacks that happen across data sets is different. So the major challenge that we can look at these data sets is lack of cross-domain coverage, right? Lack of cross-domain coverage means uh, the data sets are not capturing sufficiently large domain knowledge, right? The data is heterogeneous and enrichment. Data needs, you need to capture heterogeneous data, and also these data needs to be enriched, right? And if the attack patterns are intelligent, these data sets or the ML solutions or DL solutions that you are going to build with these data sets are not going to work when you build any kind of cybersecurity solution, right? Similarly, you have most of these models are centralized data collection models. When you have something like a centralized data collection model, that will have impact on scalability, that will have impact on privacy, right? So that's why you need to think of alternate solutions, right? And also majority of these data sets suffer from ambiguity. Ambiguity means when you are capturing a network packet, looking at the network packet, if you are unable to distinguish whether the network packet is benign or malicious, right, then it might cause an ambiguity in the model if you have sufficient variations, right? So that basically is a major challenge that needs to be addressed when you are dealing with these type of data sets, right? And also incompatibility with federated learning and simulated nature of data. Means majority of the data that is collected here, as I said earlier, is not from the actual attack environment, but it is a simulated attack scenario, right? So that is why majority of the solutions that are provided are like trying to capture comprehensive behavior, because we do not actually know what is the behavior to look for, right? So that is why these solutions needs to evolve, and we need to adopt different other type of techniques to build a more effective solutions in this particular domain. Main important point is most of this data that is collected is through network traffic, right? So network traffic sometimes, as I've said, may not be sufficient. So you need to understand how other evidences that you can collect to augment with network traffic. For example, you have encrypted communication. Let us say the communication is happening end-to-end encryption. So even if you capture a network packet, nothing much can be known because lot of the content is encrypted, right? And if the attackers use evasive techniques like some kind of randomization or some kind of padding they use, then your model might not be able to detect an ongoing attack, right? So that is why you need to have you need to augment the existing network traffic with other types of data like system logs or device logs, right? You need to integrate cross domain features, you need to augment attack scenarios, right? That basically addresses these gaps in existing data sets, right? So more or less the point that I'm trying to make is the current machine learning enabled detection techniques needs to be worked out. There are a lot of gaps in existing systems that needs to be addressed when you are designing solutions. And also you need to explore different other types of solutions like federated learning techniques, which are more privacy preserving compared to the existing machine learning techniques, right? So with this particular statement, I would stop here. There are certain experiments that I wanted to show, but because of the like lack of time, I am trying to stop here. Right, I will share the slides. You can actually go through, and if there are any specific queries, you can mm, like reach out to me, right? So I will stop here and I will take any questions that you might have be having right now, right? I'll just scan through the slides. You can see there are a lot of experiments that we have done. Whatever the points that I have said right now, right? These have been experimentally validated. That is why those gaps that we have identified, we have shown here, right? We have done several types of experiments. So these are the conclusions, right? So this basically this work that I am showing here is part of a large project that I am currently handling. It is called as a federated learning and fog computing based framework for IoT security. It is sponsored by MIT Cybersecurity R&D division, right? So I acknowledge this particular project here, right? I have copied some images in this particular presentation. So the major they have been referred at proper places. So like this is a disclaimer I am giving, right? With this I will stop my talk. I will take any questions that you might be having regarding this. Sorry for the uh, long basically. I know that it's already 8 o'clock. So I know that you are exhausted, so I will quickly take any questions.
Dear participants, you can ask any questions. Yeah, thank you, sir, Rakesh sir, for your wonderful session on the attacks in IoT systems and various threats. Yeah, it's a good session, sir. Yeah, you have given a valuable insights on security, cyber security, and IoT security systems, sir. Yeah, thank you very much, sir.
Thank you, sir. Means means without sounding it repetitive, please address me as Rakesh.
Okay,
And
okay, okay.
thank you for this opportunity. Means I have a lot of people here who are much experienced than me. So it's glad that I could present some of our work that we have been doing. I try to keep it as simplistic as possible so that people who are working in this field can try to start from this particular it's basically a starting point. I have shown you a lot of resources that you can use, and if you have any question later also how to use or where to start, right, you can reach out to me as the principal has already said that this particular FDP should translate to, and also Shankar sir also mentioned that this particular FDP has to translate to some knowledge for all the faculty people and students who have joined. So I am willing to respond to your emails or even in the chat wherever possible, right? You can also direct questions to sir and he might relay to me, right? If there are any resources that you might need, you can also visit our group's website. We have a lot of resources available there. You can actually also download them from there, right? So thank you so much, sir. Thank you again.
Thank you, Rakesh sir.
Sir,
Further, we will contact if
Rakesh
any
sir
services
has
are
explored-
required from the kids college, sir.
Yeah, somebody is saying something. Somebody is having some question.
Yeah. Okay.
Sir, good evening, sir. My name is Vishwanath Naveen.
Uh-huh.
Rakesh sir has explored so much of information which is very useful for us.
Mhm.
Sir, actually there is a text box is not enabled in this chart. Let me know the information regarding Rakesh sir. Sir, may I get your
Chat
number
box
or
is not
email ID,
enabled.
whatever?
He is saying that chat box is not enabled.
Yes, sir. Sir, may I get your contact details, Rakesh sir?
Yeah. So means my email is Rakesh @IITG 3ISTG.ac.in. So I don't know whether I could. Yes, I don't know whether I can write in the chat box. Let me see if I can write in the chat box. I can. I will just write it here also. Oh, I cannot see this. Okay.
Actually, I joined as a research scholar, sir.
No, if you are having a WhatsApp group, the Venkatramulu sir will be keep your mail ID into the WhatsApp group, sir. No issue.
Yeah, so I think sir will share my email ID. So please contact me without hesitation. I will respond. Thank you.
Thank you.
Thank you
sir.
very much.
Nice session, sir. Thank you very much.
Thank you, sir.
Nice
Thank you, sir.
Very good
Thank you.
information, sir.
Okay, sir. I am logging out now.
Thank you, sir. Thank you, sir.